G'day guys, welcome back. Just a nice little short one for you today. As you can see, I've printed out the motor mount as we were talking about in the last clip before I tidied up the tail of the bike. You can see I've made some yellow marks on the brackets. It's just a bit easier for you guys to see. Yeah, I've kind of cocked up a little bit on the bracket, so it's a bit hard to see, but you can see the engine mount here, which is the original one, hasn't got quite enough clearance on this relief I've put on the 3D print here, and same as on the bottom one as well. So it's actually holding it out a tiny bit, so the alignment of the holes is not allowing the bolt to come through. So that's not a huge drama to fix in the model. I can remedy that. I can just take a little bit more out of this hole in the 3D model, and this front stabilizing bracket to stop it from torquing is I've dropped it down way too low, so you can probably see that the hole's actually below the top of this lower chassis rail here. So what that means is I need to raise this eyelet up a little bit to allow me to put a cross brace across there in steel tube, and then weld a lug on the top that allows this to be bolted to that lug, which helps stabilize the whole bracket from twisting under torque. So you can see that it's 20mm thick, so it's pretty beefy piece of material. I've had to make it 20mm thick because I'm going to put a helper bearing here on the front of the shaft. These bearings are rated to 7 kilonewtons inside the motor. That's a static load and that's maximum loading. Electric motors typically have very fine tolerances between the rotor and the stator, so we don't want to be flexing that shaft, which can cause an issue called tunneling in electric motors, where the rotor starts to wobble and hit the stator. So I'm putting a helper bearing on the front nose to take the load that the chain, the radial load that the chain puts on the shaft when you tension the chain. So that'll take the brunt of the load and transfer that into the bracket rather than into the shell of the motor. And then the bearings in the motor only have to keep the shaft steady inside the motor and not have to worry about radial load on the front and rear bearings of the motor. So the motor actually doesn't form any part of the structure. It's bolted onto the front housing of the motor. So all these bolts do here is stop torsional movement on the motor. So and a little bit of flex. I'm really glad with the way how rigid the bracket is, even with the 3D print. So this 3D print only has like 5% fill, so it's mostly open space, and it's pretty stiff there. I mean, you can see there's a little bit of wobble in it, and that's because I'm wobbling this front mount. Once that mount's locked down, there's going to be very little movement in this bracket at all. So I'm pretty glad with the way that the bracket puts up with that kind of load. It's also really good. You can see that we have the back side of the motor is inside. It's a little bit hard to see, but it's inside well and truly inside the foot peg, which is really important. And when you look at the original motor, you've got the clutch basket housing, which comes out to about here, right up at the front. So I'm actually narrower down the bottom than I was originally on the machine. And we can also see that we've got pretty good alignment from the front of the motor nose on the shaft here through. You can see up here, there's kind of the original wear on the bumper that's the center of the shaft there near my finger. Again, it's pretty hard to see. Like, so we got we got that there. So yeah, alignment's looking good. Clearances are looking good. Unfortunately, a couple of small cock-ups there, but that's, you know, the name of the game, I guess, when we're playing in this space. Yeah, so I need to readjust this. I'll reprint just to make sure. Then I'll send this bracket off to a CNC machine shop and get it machined up out of some T6 and anodized, and that should be ready to go. I've ordered the motor, so that motor will be arriving in the next 6 to 10 weeks, depending on freight and COVID and the whole disaster that's happening at the moment. And yeah, that'll get me going on this part. In the meantime, I'll probably fabricate a small piece of pipe to go across here, and the lug, and I'll probably do all of the welding, or a lot of the welding, at once on the machine, just so I don't have to get the welder in and out a million times, because I've got a tiny workshop. And yeah, that's about all, folks, for now. I'll keep you up to date. Catch you soon. Thanks for watching. Bye.